Hello, how are you? How are you? You're fine. Can you hear me well? Can you hear me well? Can you hear me well? Hello, Miguel. Can you hear me well? Okay. Can you see me? I think you can't. Can you see me? Yes? Can you see me? Diana, can you see me? Maria? Yes? Robotic. But I worry because I don't know if you can see me. Can you see me? I know. So, now we're going to start. There is some technical failure. So now we're going to start, and we have a lot of work today. So please go to your text part. We're going to talk about electricity. We're going to watch to some video clips, four of them, all in all. It's you remember you have to we have to know things about electricity. Very interesting and important and awesome thing. Uh, the most important thing about electricity is the definition. Definition is that electricity is the flow of electrons. Okay, and not only that, but electricity is a kind of a form of energy. Okay, and any other form of energy can be transformed into electricity. And electricity is what we normally use to live, to use energy. And with that in mind, remember that there are two different kinds, two types, two sorts of electricity. One of them is called static electricity. Static electricity means stationary electricity, when electricity gathers just in only one place. And the other form of electricity is current electricity. Good. With that in mind, I'd like you to watch this interesting video about electricity. This is the basics of electricity. Pay
Vive en
attention.
España y es propietario de 3 o más vehículos. No omita este vídeo. El rastreo de vehículos.
Electricity is all around us, and most of us use it every day. But do you really know what electricity is? To really understand electricity, you first have to start with an atom. Everything in the universe is made up of atoms. Let's look at this ant. We think of ants as being pretty small, but atoms are smaller. Much, much smaller. Atoms are so small, in fact, that one ant is made up of too many atoms to count, more than 1 billion. If you take an object and keep breaking it down to smaller units, eventually you'll be left with only atoms, which we can call the building blocks of everything. Atoms have a couple of different parts, and a really important part of an atom is called an electron. Not all atoms have the same number of electrons. The number of electrons in an atom can change because electrons can move between atoms. Electricity is the movement, or flow of electrons from one atom to another. This flow of electrons is called current, electric current. Electrons can move in all materials, but they can move through some materials better than others. If electrons can move quickly and easily in a material, then that material is a conductor. A conductor is anything that allows electric current to flow from one point to another. The opposite of a conductor is an insulator. An insulator is a material that does not let electrons move well and doesn't conduct electricity. Have you ever seen the inside of a wire? The inside is usually made up of copper or another conductive metal, while the outside is made of plastic, an insulator. The copper wire helps the electrons flow, while the plastic insulator helps keep the electricity from being wasted and prevents us from being shocked. To use electric current to power things, you have to create a complete pathway for the electric current to follow. This is called an electric circuit. An electric circuit is like a racetrack of conductive materials that let the electrons flow in a specific way. For example, let's try to light a light bulb. First, you need a power source, like a battery. Next, you need to connect wires to the battery, and finally, the light bulb. Presto! Just like that, the circuit has been completed and the light bulb lights up. To learn more about electricity and circuits,
Good. So this is the basics of electricity. And now go back to our text part. So electricity is the flow of electrons, and electricity is an energy source. We're repeating. And now we have two different kinds of electricity: static electricity and current electricity. And along with it, we have two different materials: conductors and insulators. So remember, when electrons move, they carry electrical energy from one place to another. And this is called current electricity or an electric current. And the current electricity needs an electric circuit. So, and you have here a picture with many things that are needed to electricity to flow. So you have here a plug, here you have a socket, you have here kind of tool that is made of metal. All of these are needed for electricity to flow. And here you have a globe, maybe a globe made of rubber or plastic. This is an insulator. Okay? This answers, and the rest, I think, yes, the rest are conductors. So, and now, with that in mind, I'd like you to go to the next video about conductors and insulators and electricity. Now, please pay attention.
Todo empezó como cualquier otro viaje a casa.
Hey, Matt, why have you got that look on your face? Because my mom has told me off. Why? Do you remember yesterday's storm? Oh, yes, it was terrible. Many branches fell off the trees on my street, and one of them cut an electric wire. And why did your mom tell you off? Because we were walking down the street and I saw a wire on the floor, so I ran to pick it up to show it to my mom. Just before I touched it, she shouted so loudly that I was stunned. The wire could have transferred electricity to you. You're so absent-minded, Matt. Don't you remember what the teacher told us some time ago when we were talking about the electricity? Miss, there was an outage today in the playground.
It was an outage, Matt. Only a light bulb went.
What happens when there's an electricity outage?
That's an interesting question. Let's all think first what electricity is. Can any of you tell me what electricity is?
It's something that flows inside the wires.
Okay, but electricity doesn't only flow through the wire. There are also other materials that allow electricity to flow through. That is, materials which allow electricity to flow easily. That's why they are called good conductors. There are good conductors and poor conductors. Poor conductors.
Can you see the difference between good conductors and not so good conductors? So can you see the speed of the electrons in this good conductor, and can you compare it to the speed of these electrons in this not so good conductor?
Conductors are those that don't allow electricity to flow, or only allow a little. Are wires good or poor conductors? Wires are used to connect electrical devices to the electricity that comes from the street. If you examine a wire, you'll see it has metallic threads inside, wrapped by a rubber or plastic cover.
Are the wires in the street similar to those we have at home?
The wires in the street are prepared for a lot of electric current to flow through them. Think that those wires supply whole neighborhoods with electricity. But both wires in the street and those in our homes contain a good conductor material inside, through which electricity flows, and a material that doesn't conduct electricity, the rubber.
You see, this is the wire, maybe copper, and this black part here that is rubbing the metal conductor is an insulator. Okay, have to be very careful when you touch any wire.
Part on the outside.
And the rubber they have doesn't allow electricity to escape?
That's it. Because rubber and plastic don't conduct electricity, and therefore electricity has no option but flowing through the metal conductor that is inside the wire. That's why the rubber covering the wires is called an insulator, because it keeps electricity inside the wire and prevents it from escaping.
What would happen if the rubber were not there?
If the wires weren't covered by the insulator,
I imagine this is the wire, but no insulator at all. So you touch it, you can have a short circuit. This is very dangerous. You can't do that. You have to be very careful with that.
electricity would escape through the sides and wouldn't reach our homes. Besides, it'd be very dangerous because anybody touching the wires would be electrocuted.
Then our body is a conductor, because if we must be so careful with electricity, it's because our body can conduct electricity.
This is important. So our bodies are conductors, not very good conductors, but conductors. So you touch a wire, you are allowing the electricity to flow past you, and you can get electrocuted. Okay, you can die. So pay attention to that.
Isn't it? You're right, Matt. I hadn't thought about that before. So, to avoid any risk, we should be careful not to touch anything having electricity. Like sockets, wires without insulators, the inside of lamp sockets, or wires that have fallen after a storm on the street. That was really dangerous. We must be very careful with the electricity. Hey, don't forget to
So you good? And now please, let's go back to, in this case, our exercise part. And you had an exercise about electricity. In this case, about static electricity. We want to watch another clip about static electricity. But this girl, can you see, has her hairs standing on. And why is it? Because there are here in the balloon there is an amount of electrons, a lot of them. They are not in balance here, and they are not in balance here. As here there may be a lot of electrons, this is negatively charged, and here is positively charged. And you know that two like poles attract each other. That's the reason why the hair in this girl is standing up. So this is the explanation about electricity. And now, before going to check this exercise, please, we have another clip. So pay attention. About static electricity.
It can strike without warning, at any moment. You may be walking across a soft carpet and reaching for the doorknob when suddenly, zap! To understand static electricity, we first need to know a bit about the nature of matter. All matter is made up of atoms that consist of three types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in an atom balance out, which is why most matter you come across is electrically neutral. But electrons are tiny and almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged.
So, if there is an object with more protons, positively charged particles, and electrons, this object gets positively charged. This is the body of this girl. Okay?
While the one with more electrons accumulates a negative charge. This situation is called a charge imbalance, or net charge separation. But nature tends towards balance. So, when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they're most needed, either jumping off the negatively charged object or jumping onto the positively charged one, in an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static discharge, is what we recognize as that sudden spark. This process doesn't happen with just any objects. Otherwise, you'd be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator.
So, when a material is an insulator, maybe plastic or maybe rubber, it's more likely to occur static electricity. Okay, it's more likely. Good.
When you walk across a rug, electrons from your body will rub off onto it, while the rug's insulating wool will resist losing its own electrons. Although your body and the rug together are still electrically neutral, there is now a charge polarization between the two. And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons hop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature.
This is very important. Okay, so you have to be very careful when you are going for a walk. Okay, and there is a storm there. Okay, happening there, because you have to look for a shelter. Given the fact that there are static electricity in the atmosphere.
In certain conditions, charge separation will occur in clouds. We don't know exactly how this happens. It may have to do with the circulation of water droplets and ice particles within them. Regardless, the charge imbalance is neutralized by being released towards another body, such as a building, the earth, or another cloud in a giant spark that we know as lightning. And just as your fingers can be zapped over and over in the same spot, you better believe that lightning can strike the same place more than once.
So, very good. Let's go back to our material. This is the exercise part, and you can take part in this exercise. Very easy. So remember, I need your contribution. We have to complete the gaps in text. So, how static electricity works. And we have electricity is caused by, we can choose between electrons, protons, and neutrons. Electricity is caused by, yes, by electrons. That's why it's called electricity. Electrons, electricity. So each electron has a small, and we're talking about the type of charge. So we can choose between positive, neutral, and negative. Talking about electrons. Electrons have a small, yes, negative charge. Negative charge. Good, very good, very good. An atom has an equal number of electrons and protons. Protons are positively charged particles in its nucleus. So atoms are, and you can choose between negative, positive, or neutral. Talking not about electrons now, not about protons now, but about atoms. Okay, in general, all in all, atoms are, yes, see, neutral. Since the atoms have no electrical charge, the molecules have therefore positive, negative, or no charge either. In the correct correct answer is for number 4. We can choose between positive, talking about molecules. Remember, atoms are neutrals, and molecules are compounds of atoms. So positive, negative, or no charge. Yes, no charge either, and no does the rubber. So now, suppose you rub a balloon on your pullover over and over again. As you move the balloon back and forward, you give it number 5, energy, electricity, peace, no way, this is a nonsense. Energy is a nonsense. Electricity. Good. So let's follow. The energy from your hand makes the balloon move, and as it rubs against the wool in your pullover, something in the rubber molecules are not free. So 6, atoms, no. Molecules, no. Electrons. So 6 is B, electrons. And gather on your body. This leaves the balloon with slightly too few electrons. Since electrons are, again, 7, positively, negatively, no charge, no. Positively, no. B is the right answer. So, since electrons are negative charge, having too few electrons makes the balloon slightly, remember, electrons have a negative charge, and in this case, remember that the balloon has too few electrons, so as a result, the balloon gets 8 positively, negatively, no positively, because it had lost a lot of electrons. Good. So your pullover meanwhile gains these extra electrons and becomes with more electrons that are negatively charged. Number 9 has to be no charge, positively, negatively, yes. C, negatively charged. Your pullover is negatively charged and the balloon is negatively. Remember that these electrons come from the balloon. The balloon is positively charged and your pullover is negatively charged. So number 10 is negatively charged. Okay, and we have here something opposite, like same charge attract. Same charge attract, no way. Like, no, because it's a synonym. So opposite charge attract. So your pullover sticks to the balloon. Very good. And here you have some objects, and you have to classify them between electrical conductors or insulators. And as a rule, when you see some objects that are made of metal, they are conductors. If you see some objects that are made of wood or rubber or plastic, okay, plastic, this is plastic, this is wood, and this cap is kind of okay, this is another insulator. This paper book is made of paper. This is another insulator. This is a can made of metal. This is a conductor. Okay, this is a nail, another conductor. This is a marker made of plastic, another insulator. Very good, very good. Now go back to our text. So remember, we have here conductors and insulators, and you have here 5 electrical conductors. Very good. So electrical conductors are silver, gold, copper, steel, seawater. Remember, gold is one of the strongest electrical conductors. But as gold is very difficult to find and to use, and silver the same, we use normally copper. And here you have the picture of 5 electrical insulators: rubber, glass, oil, diamond. Diamond is made of carbon, and dry wood. Why dry? Because wet wood has water, and water has normally has something dissolved in it, and it makes water a good conductor. Very good. Now, I want to see about simple electrical circuit. But before, I like you to watch to another interesting video. So about current, electricity, and the circuit diagram. And this is the last video of today's class. So pay attention.
In the last video, we saw symbols of a few basic electrical components used in a circuit.
You get to understand that, okay? And you have to learn that these are symbols. You have to draw some circuits. You have to do that, okay? So you have to make a project about electricity, and you have to learn this symbol. This is an electric cell. This is a battery, okay? And this is the thing that powers the circuit, and this is a symbol. Remember that. To put it. Okay, let's start.
In the last video, we saw symbols of a few basic electrical components used in a circuit. This is a symbol representing a battery, which is a 1.5 volt cell. This bigger line represents a positive terminal, and the small one represents a negative terminal.
This is important. So, the large side, this is the positive, and the other is the negative. So this is important. They are not the same length. Okay? They're different. This is the positive, that's the negative. Okay? And the electrical current goes from the positive to the negative. It's important.
This symbol is used for the bulb connected in the circuit. It is just W written upside down in this way, and
this is an electric bulb. This is called a resistor. This is another wire, kind of wire, but this is not a very good conductor. This is a conductor, but not very good. So you want all these electrons to go all along this part. So this part is starting to glow and to heat up. That's why this is a resistor, because it offers resistance to the pass of the electric current. But finally, the electric current goes ahead. Okay? So as a result, this is the thing that glows and warms.
Closed in a circle. So if we were to draw this simple circuit using the symbols, then how would we do it? Just draw the symbols for the electric cell and the bulb first.
Okay, so this is the battery. The battery, okay, positive and negative. This is the battery. This is the positive pole, and this is the negative terminal. And this is the symbol for the resistor, okay? And this light bulb is the resistor. And you have to join one with the other. And you do that with the wire, okay? And the wire you have to draw it, this is important, with right angles.
Then using straight lines for wires, join them together.
Can you see? These are right angles. You can do it this way, okay? This is good for arts, but for electricity and for natural science, you need to draw right angles. Right angles.
This is the circuit diagram representing this circuit. It was simple to draw, wasn't it? You can even show the direction of electric current in the circuit with arrowheads.
Pay attention, this is the direction of the electric current from the positive pole to the negative pole, okay? Although actually it's the opposite. Okay, this is a convention, Why is the opposite? Because electrons have a negative charge, so they are here, they are stored here, and the only way they can go is the other way. But we take it as a convention that electricity goes from the positive pole to the negative pole, all along the cable and passing through the resistor.
So the electric current is flowing in this direction from the positive to the negative terminal of the cell. Now we had seen in the past that this is not the only way to light up a bulb in this circuit. For instance, if we interchange the wires connected to the two terminals of the bulb, then the bulb will still glow.
Still go because in this case, this is the direction of the current. So, this way. So, important thing is that the circuit is closed. This is the important thing.
This is because the circuit is still complete and all the terminals of the system are occupied. Can you draw the circuit diagram for this circuit? Why don't you give it a try? If you look at this circuit, the positive terminal of the cell, which was initially connected to this terminal of the bulb, is now connected to the other terminal. Similarly, the negative terminal, which was initially connected to this terminal, is now connected to this one. So how will the circuit diagram of this circuit look like? This is the circuit diagram. Compare it with this one.
There's the difference, the battery here, and the battery here. The difference. So in this case, we have here the positive terminal and the negative. Positive terminal on your right hand, and in this case on your right hand, this is the negative terminal. Okay, and this is the direction of the current in this case, and here you're going to see that the direction has changed.
You see that we've just reversed the direction of the battery. Hence, the electric current in this circuit is flowing in the opposite direction. So the electric current can flow in either direction. As long as the circuit is complete, the electricity will flow and the bulb will glow. Let us look at this circuit now. How many components does this circuit have?
Attention, here we have something new. Okay, this is a switch. We have a battery, a resistor, we have the wire, the cable, and here this is new. This is a switch.
Yes, 3. A bulb, cell and a switch. What is the symbol for switch? There are two symbols for a switch. This symbol is used when the switch is on and this symbol is used when the switch is off. If we were to draw a circuit diagram for this circuit, then here is what it will look like. Note that there will be two circuit diagrams for this. This one is when the switch is off and the electric current is not flowing through the circuit.
Okay, so you got to do this exercise in today. For today, remember, you got to draw it. This is the symbol of the battery. This is more or less the symbol of the resistor. This is the symbol for the switch. Okay, if you put the switch in this position, the switch is off. No current, no electricity. Okay. And at right angles, you have to draw the other component that is the wire. Remember that?
We see that no arrowheads are shown here. This circuit diagram is when the switch is on. Here, the circuit is complete and the current is flowing. The arrowheads are used to show the direction of the electric current, which is always from the positive to the negative terminal of the battery. Now here is a question for you. We know that when the electric current flows between the two ends of the filament heats up. This heating up of the filament results in its glowing, and this is how we receive light from the bulb. But if this filament is broken, then
what happens? This filament is broken, so the current can go, okay? Can't go. There's no flow of electrons because here is no way to go. So no electricity in this case.
will the bulb glow? No, it won't. This is because if the filament breaks, the circuit will be broken.
So, very good, very good. Now, before finishing this part, please go in this case to the text part. The text part you have here the same thing that you have just watched in the documentary. So this is the battery, this is the light bulb, this is the resistor, this is the switch. In this case, this is closed, so it allows the current, the electricity current, to go along the wire. And this is the wire. Remember, right angles. And these are the components of an electric circuit. This is the battery. You can call battery, generator, or cell. It all depends. Okay. You have to read this part. And this is the wire. Just a line. But remember, when you are drawing a circuit, you need to put the circuit in right angles. Okay, when it's needed. This is the resistor or the load. Could be a light bulb, an amp, refrigerator. This is the symbol, or this. Okay, or this W that was upside down. Now, this is the switch. This is open, no electricity. This is closed. Okay, good. And this is a very simple circuit. So the battery, wire, the light bulb, or the resistor, and the switch. In this case, the circuit is not closed. It's open, no electricity. And remember, this the long terminal is the positive pole, and the short terminal, the negative pole. That in mind, you have here another exercise. So, I want to correct it. Number 13. First question is very easy. So, what supplies energy in an electric circuit? What supplies energy? Conductor, light bulb, wire, or the battery? You think? Clearly, the battery. 13.2. Which material is a conductor? A conductor. Plastic, silver, glass, wood. So, the right answer is B, silver. Next. Which item could be a resistor or a load, a resistor, in a circuit? A light bulb, a wire, a battery, a pencil? No. The true answer is A, light bulb. 13.4. In a simple circuit, why does the bulb light when you close the switch? Why? Because the switch produces electricity? No. Because closing the switch completes the circuit? Could be, maybe. Because closing the switch breaks the circuit? No. Because the battery goes flat? No, the correct answer is B, because closing the switch completes the circuit. Finally, in a simple circuit, why does the bulb go out when you open the switch? When you open the switch? Because the battery is powering the circuit? Nonsense. Because the battery goes flat? Could be or not, it's not sure. Because opening the switch breaks the circuit? Or because too much electricity flows through the bulb? No. The only correct answer is C. And take a look at the exercise number 14, because not all of you did it right. So, in this circuit, there is something wrong. Okay, we have here a battery, we have here two resistors, we have here the wire. So, what is wrong is that there is no connection between this terminal and the battery. So, this is why the circuit is wrong. B. Pay attention. Pay attention. So the key is the switch. This is the switch. Okay. If you look closely, you can see that the switch is open, and that's why there is no electricity flowing. Okay, because it's not closed. And finally, here But see, you see this image, you can see the two terminals are here in this part. So there is electricity, but this electricity can pass through the resistor. So the resistor is of no meaning in this circuit. Very good, very good. Remember, you have to do these three exercises for today, number 15. These two exercises, sorry. And when you draw this simple electrical circuit, remember you have to use the symbols, the correct symbols. It's the cable. You have to draw the cable with right angles. Good. And now we are finishing this part. I see you in just